Hello everyone, this is Raghu and welcome back to the ITversity YouTube channel. So today we have a brand new course on Apache Spark and DataFrames, complete hands-on. So in this particular course, you will learn the basics of working with DataFrames using Apache Spark. And the good news is that you will be able to practice whatever you see in this course absolutely free. I will tell you how. So before you jump into the course, I want you to check out the first video in this playlist, which talks about how to get started with Databricks Community Edition for absolutely free. So if you are somebody who would like to learn Spark, then one of the prerequisites is that you need a Spark cluster. Databricks give you an absolutely free cluster in the cloud, and it is easy as 1, 2, 3 to sign up and get started. So check out the first video, create a free account, and then watch this video. The second thing that you suggest, that I suggest to you is basically to go through the second video in this playlist, which talks about RDD tutorial. Now that video will have a lot of information about Apache Spark, and you will also learn about RDDs, which are the core building blocks in Spark. Now, should I watch the whole video to start this video? Absolutely not. You can watch it whenever you have free time, but it is one of the highly recommended videos from my side. And let's see what we are going to cover in this particular course. So we will start with a brief introduction about Apache Spark, and then we will start talking about data frames. We will use one of the popular retail sales data set. We will read the data into data frame. We will go through some of the transformations, aggregations. We will even discuss some of the file and folder level commands, which are very useful on Databricks, right? So if you're somebody who has not subscribed to our ITversity YouTube channel, please do so. Spend a second by clicking on the subscribe button, and let's get started with the course right away.
One of the important aspects with respect to learning Spark is having proper datasets. Databricks out of the box provides quite a few datasets. First, let's go to the details about the datasets provided by the Databricks. For that, I'm actually creating a new notebook. Let me say new, then notebook. Then let me rename as Explore Databricks Free Datasets. Again, this is based on Python. You can see here. Now, if you wanted to review the datasets, you should be able to use something called as magic command. The magic command which you are supposed to use is nothing but %fs. Any command that starts with percentage in a notebook environment is called as magic command. On top of %fs, there are also other magics such as %sql, %python, %scala, etc. Depending upon the need, I'll cover the details with respect to other magic commands at a later point in time. For now, just keep it in mind to review the free datasets provided by Databricks. You should be able to use something called as %fs magic command. Underneath it, there are several commands. The most important command is nothing but ls. ls is primarily to list the files. After specifying the %fs and ls, you have to specify the path. The path should start with the DBFS, then colon, then /. Then you have to say Databricks-datasets. This contain multiple subfolders. Those folders have relevant datasets. Depending upon your preference, you should be able to use whatever dataset you wanted to use. For the rest of the course, I'll be using retail dataset. Once the command run, we'll review the output. We'll pick appropriate folder, and then we'll take it forward. The dataset we wanted to use is nothing but retail dataset. The retail dataset is under online_retail folder within Databricks-datasets. In this case, we should be able to improvise by saying %fs ls, then dbfs Databricks datasets, then online_retail. Then you can run this again by hitting Shift Enter. Then it will actually show the contents of this folder. If you look at this folder, it have another subfolder called as data-001. Let me copy this and then let me say %fs, then ls, then paste. Now let me run this once again. You should be able to see a file called as data.csv. This contain comma-separated records. If you wanted to review the data in comma-separated files, you should be able to use a command called as %fs head. Then you have to specify the fully qualified path for the file. Let me paste here. Let me run this. We should be able to see the output. The output is nothing but this one. It have only shown some of the records at the beginning. You can also see the header. This file have header. Header contain the column names. The column names are nothing but invoice number, stock code, description, quantity, invoice date, unit price, customer ID, country. So using this dataset, we should be able to explore Spark in this Databricks environment without worrying too much about uploading some other datasets. I hope you are clear about using %fs commands to review the existing Databricks datasets, and also I hope you are clear about the datasets which we are going to use, the dataset which we are going. The head command will only show first few records. You can see first few records here. Also, you can see the first line here. The first line is nothing but header. It have the column names. The column names are nothing but invoice number, stock code, description, quantity, invoice date, unit price, customer ID, and country. Using these columns, we should be able to access this data once we start using Spark concepts such as Spark DataFrames, Spark tables, etc. That being said, %fs is the command which you can use to review the datasets that are already there as part of Databricks Community Edition. The base folder is nothing but Databricks-datasets. In that, we have several subfolders. We have picked online retail. In that, again, there is one more subfolder which is nothing but data-001. This entire path contain one file called as data.csv. We have even used head command to review first few records in the CSV file. We have realized that the CSV file have the header and then records. Now, using this dataset, we'll explore Spark in this Databricks Community Edition environment. Yeah, we have reviewed the datasets. Let's get into the details about processing the data in Databricks environment. Either you should be able to use PySpark or Spark with Scala, or you can also use Spark SQL. Even R is supported, but with respect to this beginner's course, we will predominantly focus on PySpark and Spark SQL. First, let me go to the details about how to process the data using PySpark. Then we'll talk about how to use Spark SQL. In case if you wanted to process the data using PySpark, you need to first create something called as Spark DataFrame. Let's get into the details. Here I am creating a new notebook. Let me say new, then notebook. Let me give a name as getting started with PySpark. Already we have chosen a dataset. The path for the dataset is available in this recently used notebook, which is nothing but Explore Databricks free datasets. Let me go into that. Then let me copy paste this one. Here I am picking only the folder path, not the fully qualified path of the file itself. File is nothing but data.csv. Now let me go to recents once again. Let me pick getting started with PySpark. This is the notebook which I am going to use to demonstrate PySpark capabilities within Databricks Community Edition. Now let me first review whether the path is correct or not. For that, again, I have used %fs ls with the path. You can see the outcome. The path is correct. Now we should be able to say spark.read.csv. Let's also assign to a variable. Let me say df equal to. Then let's make sure we copy paste this path. We have to specify the path in a single quotes. Even you can use the double quotes, because when it comes to Python, strings can be enclosed either in single quotes or double quotes. On top of this, we also need to have additional keyword arguments. The additional keyword arguments are nothing but these. One is header, because with respect to the path, the file which we have, it have the header. Hence, we have to say header equal to true. Then other keyword argument is nothing but infer schema. Even for this keyword argument, the value should be true. Let me say true. Now let me run this. It will create something called as a data frame. The variable name is nothing but df. It is of type data frame. Let's wait until it is run. Then we will take it forward. Now you see, it have started processing the data in the file. The data frame is created. You should be able to click on this to expand. You can actually see the details with respect to columns and also corresponding data types. In case if you say infer schema equal to false, or if you don't pass infer schema, then by default all the columns will be of type strings. Here, as we have said, infer schema equal to true. For quantity, unit price, and customer ID, it have used numeric data types. Integer and double are of numeric type. With respect to others, as we have string values, it have considered string as the data types. That being said, because we have used header equal to true, it have picked the first row in the CSV file. The first row contain the column names. It have used those column names here. If you don't say header equal to true, then it will just give system generated names such as underscore C0, underscore C1, underscore C2, etc. Why don't you give a try by removing these two keyword arguments just by passing the path and see the behavior? Definitely you will understand what is going on here. That being said, as of now, we have created the data frame by name df. Now it is important for us to preview the data. Databricks provide a special function called as a display. If you say df.display, you should be able to preview first 200 records in the data frame. Now you see it is running. Very soon you should see a very nice table. You can actually review the data. These are nothing but first 200 records in the table, or it can be 1000 also. Let's see how many records we have. It have actually 10,000. Let's scroll down further. I think it is displaying 10,000 records here. However, the file have lot more than 10,000 records. In case if you are curious about how many records the file have, you just have to say df.count. Then you have to specify circular brackets because count is a function. Once you run, you should be able to see the count. Let's wait until it is run, then we will review the count. When it comes to the count, it is nothing but 65,499. This is how you should be able to create a data frame using CSV files in the specified location. Once the data frame is created, you should be able to preview the data using df.display. Also, you can get the count using df.count. As we have successfully created Spark DataFrame and also previewed the data in the Spark DataFrame, before going further with respect to processing the data, first let's understand what Spark is all about. For that, you can actually go to official website of Spark. It is nothing but spark.apache.org. As Spark is open source, which is incubated in Apache, the URL is nothing but spark.apache.org. This is the landing page of Spark. When it comes to Spark, it is nothing but unified engine for large-scale data analytics. You can see brief introduction about Spark here. Also, you can see a bit of definition with respect to Spark. When it comes to Spark, it is nothing but a multi-language engine for executing data engineering, data science, and machine learning on single-node machines or clusters. When it comes to key features, Spark supports batch or streaming data. It also supports SQL analytics. Also, it supports data science at scale, where you have to process huge amounts of data with respect to data science. Also, when it comes to Spark, it can be used for machine learning. These are some of the key features with respect to Spark. In case if you wanted to review official documentation of Spark, you can go to documentation here. You can click on latest release and then you can take it forward. This will actually give you complete documentation related to the Spark. In this case, depending upon the version of Spark we have, we should review the documentation. Otherwise, you might see some glitches here and there. To review the version of Spark in this cluster, you can go to compute. Then you can click on IT University's cluster here, or whatever cluster you have created. Then you can see the version is nothing but 3.5.0. Here, I would highly recommend you to use only 3.5.0 documentation. For that, you just have to replace latest with 3.5.0 or 3.5.0. Now you should be able to hit enter. You can see it is 3.5.0. Earlier it is 3.5.1. Now you should be able to go to relevant pages to review the documentation. For example, if you wanted to understand how to start quickly with Spark, you can go to Quick Start. In case if you wanted to learn SQL DataFrames and Datasets, this is the page. If you want to learn structured streaming, this is the page. Spark streaming is outdated. You don't need to worry too much about it. In case if you wanted to learn machine learning, this is the page. In case if you wanted to go to PySpark, this is the one which you should focus on. This is the main one. When it comes to getting started with Spark, it talks about Spark SQL, DataFrames, and Datasets. Now, when it comes to the course, I'll be covering very basics because this is for the beginners. In case if you wanted to deep dive further, either you can sign up for our other courses or you can go through this official documentation to learn whatever you want. If you look at this Spark SQL guide, it have getting started, data sources, performance tuning, distributed SQL engine, PySpark usage guide for pandas with Apache Arrow, migration guide, SQL reference, and also error conditions. In case if you wanted to get into details with respect to Spark SQL guide, you can click on getting started. You can see code examples here. Using these code examples, you can practice. Here it is talking about reading JSON files. You might also see the details with respect to CSV files. However, I have already demonstrated how to read the data from CSV files using spark.read.csv in the notebook. The notebook is nothing but getting started with Python. You can see the code here. You can see similar code examples even in the official documentation. I hope you understood what Spark is all about, and also I hope you know where to go in case if you wanted to review the official documentation. Make sure you are fairly comfortable with it. That being said, as we have brief introduction with respect to Spark, and also as we have understood how to create a Spark data frame using PySpark, now it is time for us to explore PySpark further. As part of that process, we learn how to use PySpark to process the data based on our requirements. As we have gone through the details about how to get data in CSV files into data frame and also brief overview about Spark, now it is time for us to understand this dataset so that we can come up with the problem statements to learn Spark. In this case, I'll primarily focus on PySpark. When it comes to columns in this dataset, we have invoice number, then stock code, then description, then we also have quantity, invoice date, unit price, customer ID, and country. If you look at each and every record, you have values related to these columns. However, when it comes to invoice number, it is not unique. In this case, for each invoice, there are multiple items. With respect to invoice number 536365, there are 7 items. You can see here. With respect to 536366, there are 2 items. It might be the case that there might be more items in invoice number 536365. To confirm that, you should be able to sort the data. However, based on this, let's assume when it comes to invoice, there are multiple items. This dataset represents the items in the invoices. On top of invoice number, we also have stock code, description, etc. But we don't have the item level revenue. We have the item level quantity and unit price. However, there is no item level revenue. We can start with computing item level revenue. For that, we just have to multiply quantity with the unit price. Once we compute item level revenue, we can also go ahead and compute invoice level revenue. First, let's see how we can compute item level revenue. Then in a subsequent lectures, we'll actually get into the details about how to compute invoice level revenue. To compute item level revenue, first you need to import a function called as call. Let me import the function called as call. For that, you should be able to say from PySpark.functions. It is actually PySpark.SQL.functions. This has several functions. One of them is nothing but call. Now let's run this. Now call function is imported. When it comes to DF, which is a data frame, it have these columns. They are nothing but invoice number, stock code, description, so on and so forth. On top of these columns, I also wanted to have item revenue. The way you can add additional columns to the existing data frames is like this. You can use something called as with column function. Let's say df.with column. Then first you have to specify the column name. Let me say item revenue. Then we have to use appropriate expressions. In this case, we have to say call of the column name which we have to multiply is nothing but unit price. So let me say unit price. When it comes to unit price, this has to be multiplied with quantity. The column name is nothing but quantity. Hence, we can say call of quantity. If you don't use call function like this, it will try to multiply using these strings, which is not possible. Call function will make sure the Spark engine interprets these as column names. Now, you should be able to assign to a new variable. Let me say df itself. We can say df equal to df.with column, and then you should be able to specify the column name. Then second argument is nothing but expression. The expression contains the multiplication between unit price and quantity. The reason why we have to do this is when it comes to data frames, they are immutable. They cannot be changed. However, once we apply functions, if we assign to same variable, then the variable will be replaced. Now let's run this. The data frame is created. You can expand this. You can see item revenue. In case if you wanted to preview the data, you can say df.display. Then you can run this. You should be able to preview the data. The data will also have additional column item revenue. You should be able to see the actual revenue with respect to each and every item in this dataset. Now let's scroll towards right. You can see the outcome. However, you can see the result is not rounded appropriately. To make sure it is rounded appropriately, you can also import a function called as round. Now you need to rerun this again. Then here you have to pass this to round. Round takes two arguments, either column name as expression as first argument, and then the second argument is nothing but decimals to which the values should be rounded. In this case, I would like to round to 2 decimals, hence I am specifying 2 here. Now let me run this once again. It have ran successfully. The data frame is created. However, the logic haven't run because Spark follows something called as lazy evaluation. You just have to run additional functions on top of data frame to actually process the data. Now it is running. I think it have already ran. You can review the output here with respect to item revenue. The revenues are actually rounded to 2 decimals. This is how you should be able to perform operations at individual record level. As we are ready with item level revenue, now it is time for us to compute invoice level revenue. Let's also look into the details about how we can compute invoice level revenue using this new column called as item revenue.
I hope you're really enjoying the course. I also hope you're practicing along the way with your Databricks Community Edition. Now, if you like this video, consider clicking the like button and throw some comments. And if you want us to come up with similar content, tech content, then let us know in the comments what topics you are interested, and we will come up with the content for you. And also share it with your friends who might get benefited from this course, and watch the other videos in this playlist to learn more about Apache Spark. So let's continue the course.
Yeah, we have successfully computed item level revenue. Now it's time for us to compute invoice level revenue. Before getting into the details, let's recap what we have done with respect to the code so far. Then we'll take it forward. First, we have come up with this code. Here we have created a data frame by name df. The location is nothing but this one. As data have header, we have said header equal to true. Also, we want the schema to be inferred. Hence, we have said infer schema equal to true. As soon as the cell is run, you should be able to preview the schema details here. These are the column names, and then these are the data types. Once we created the data frame, we have previewed the data by using df.display, and also we have used df.count to get the count. You can see the total count is nothing but 65,499. Then we have imported a couple of functions, call and round, from this module PySpark.sql.functions. Using call as well as round in with column, we are able to compute item revenue where revenues are rounded up to 2 decimals. However, the existing data frame is replaced with additional column called as item revenue. Now DF have additional column item revenue. You can review the details here. We have also previewed the data here to confirm the outcome is as per the expectations. You can see the item revenue. The data in the item revenue is rounded off to 2 decimals because of the round function. Now let's get into the details about how to compute invoice level revenue. For that, we have to group the data based on invoice number, because when it comes to invoice number, it is not unique. There are multiple items in each invoice. You can see here, with respect to 536365, we have 7, at least 7. With respect to 536366, we have at least 2. With respect to 536367, we have several of them. Using group by on invoice number, we should be able to apply aggregate functions such as sum on item revenue. Then it will actually give us invoice revenue. Let's get into the details so that you understand how we can come up with code to compute invoice level revenue using functions such as group by and sum. When it comes to group by, you don't need to import any function because it is available on top of DataFrames. However, when it comes to sum, you have to import from PySpark.sql.functions. Let me actually say from PySpark.sql.functions, then import sum. Let me run this. Now it is run. Using df, we can say group by. As part of group by, we should be able to specify the column name. The column name on which you wanted to group the data is nothing but invoice number. You can see here, it is INVOICENO. Let me specify the same here. Then you have to use dot again. Here you can line break like this. You can use something called as ag function. As part of ag function, you can actually say sum. Then you have to specify the column on which you wanted to apply sum. In this case, it is nothing but item revenue. You can review the column names once again. You can see here, it is nothing but item revenue. You can also copy paste. That is what is mentioned here. You can run this, it will work as per the expectations. However, when it comes to the column for the derived field, it will be something like sum of item revenue, which is not very meaningful. In this case, I wanted to give alias as invoice revenue. The way you can give alias is like this. On top of sum or any function, you should be able to say dot, then alias. As part of alias, you should be able to specify the derived column name. In this case, I would like to name it as invoice revenue. Now, if I run this, it will work. However, I wanted to assign to a variable. Let me say invoice revenue df, so that the name of the variable is a bit meaningful. Also, on top of it, I would like to sort the data in descending order by invoice revenue. For that purpose, I should be able to say dot, then / 2 line break, then order by. As part of order by, we have to specify the alias, which is nothing but invoice revenue. Let me specify the alias here. Also, I would like to sort the data in descending order. Hence, I have to say call and then pass invoice revenue as argument to call. Then I have to use DESC. If you don't use call like this, you will not be able to invoke functions like DESC. You have to make sure the column names are interpreted as columns using call function. Only then you should be able to use DESC like this to sort the data in descending order. If you don't use DESC, the data will be sorted in ascending order. Now let's run this. It will take care of creating a new data frame by name invoice revenue df. You can review the fields that are there in this data frame. There are only two fields. They are nothing but invoice number and invoice revenue. Now we should be able to say invoice revenue df dot display. Then run this. It will actually display the data in the data frame. You can see the outcome. There are 2888 rows. Again, the decimals are not rounded off. It is better to use round function here on top of sum. As round is already imported, we should be able to say round, then comma 2 here. This will ensure even the invoice revenue is rounded off to 2 decimals. That being said, let's run this once again. As it is successfully run, now let's run this once again. Let's review the outcome. It is still running. We have to wait until it is run. Then you should be able to see only 2 decimals with respect to invoice revenue. The data is sorted in descending order. Invoice number 541431 is the one which have the highest amount of revenue, which is nothing but 77,183.6. Let's also get number of items in each invoice. For that purpose, we can add one more function in ag on top of this one where we compute invoice revenue. Let me also get item count per invoice. For that, I should be able to use comma here, then count of invoice number. Let me also specify alias here. Alias is nothing but invoice item count. Now let's run this. Here we are attempting to not only compute invoice revenue but also to compute invoice item count. However, it is failing, saying name count is not defined because we haven't imported count function. Here first let's make sure we import count also on top of sum. Let's run this. Once it is run, let's run this. This time it has successfully ran. You can see there are 3 fields here. The new data frame is nothing but invoice revenue df. The fields are nothing but invoice number, invoice revenue, and invoice item count. Now let's run this to preview the data. This will also contain 2888 rows, you can see here. However, this time it will have 3 fields. The 3 fields are nothing but invoice number, invoice revenue, and invoice item count. With respect to 541431, even though invoice revenue is 77,183.6, there is only one item in it. Probably the most expensive item is the one which being purchased here, or it might be the quantity which is getting us that much revenue. If you wanted to get the quantity sum, you can also include sum on quantity. You should be able to review the details with respect to how much quantity we have in each invoice. In this case, if you are curious, let's also include one more here. It is nothing but sum of quantity. As the sum is imported, it will work without any issues. Let's also provide alias saying invoice quantity. Let's run this. It have ran successfully. You can see 4 fields here. Now let's run this to preview the data. Let's see the quantity with respect to invoice 541431. You can see the quantity is nothing but 74,215. Keep in mind, even though there is only one item, the quantity is significantly high. This is how you should be able to process the data to compute revenue and other aggregations at invoice level. We have used group by. On top of group by, we have used agg function. In the agg function, we have used sum and count to get the results we are looking for. As of now, we are learning basics of Spark using Databricks Community Edition. When it comes to Databricks Community Edition, it have quite a few limitations when compared to Databricks premium versions. However, we'll be talking about all the limitations towards the end of the course. But for now, I wanted to cover one of the limitations, which is nothing but untimely termination of clusters. On top of untimely termination of clusters, another issue with Databricks Community Edition is nothing but you will not be able to start the terminated clusters. In Databricks premium versions, you should be able to start even terminated cluster, but when it comes to Community Edition, you will not be able to start terminated cluster. Then how should you again start the cluster and start using Databricks Community Edition to learn PySpark or Spark? The way you have to follow is like this. You have to go to compute here. First, let's make sure we go back to the notebook. The notebook is nothing but getting started with PySpark. As of now, you see the cluster status is unknown. You can expand and see the options. There is no option to start. Also, you can go to compute here. Even though there is a start button, if you click on this and then if you click on confirm, you might see this message. It says could not start cluster IT Versity's cluster. Cluster start feature is currently disabled. In Databricks Community Edition, the ability to start a cluster is currently disabled. In future, they might change. That being said, in premium version of Databricks, you should be able to start the cluster by clicking on this. Now, in case if you wanted to start the cluster, first you have to clone. The way you can clone is by expanding this and then by clicking on clone. Once you click on clone, it will come up with the cluster name here. You can remove clone part in this. The remaining details will stay same. You can click on create compute. It will take care of creating a fresh cluster for you. You need to wait until the cluster is started. Once the cluster is fully started, you should be able to resume wherever you have paused earlier. That being said, let's wait until the cluster is started. Then we will actually take it forward to learn additional details with respect to Spark using this Databricks Community Edition. Now we got Databricks cluster successfully recreated after getting terminated in Databricks Community Edition. It is time for us to explore details about how to store processed data into DBFS using Spark itself. Before getting into the details, I would like to cover additional FS commands to manage files and folders in DBFS. Keep in mind, DBFS stands for Databricks File System. That being said, to explore additional commands related to FS, I'll be using this notebook. The notebook is nothing but explore Databricks free datasets. In this, we have explored ls command and also head command. Now we'll talk about mkdir command to create folders. Also, we'll talk about rm command to clean up folders as well as files. However, when it comes to this notebook, it is not attached to the cluster. You can see here, it is saying unknown. You have to click on this. Then you have to choose the cluster which is currently running, which is nothing but this one. Let me select this. Now we should be able to run these commands by clicking on run all. Let's make sure we click on select resource. Then let's make sure IT University's cluster is selected. Then we have to click on attach and run. It will take care of attaching this notebook to the cluster, and then it will run all the cells. We have used run all option, which we see here. Let's wait until all the cells are run. Then I'll take care of creating folders using fsmkdir command. Also, I'll cover how to use rm command to clean up the folders. Now let me scroll down here. In this case, I'll be using something called as %fs command. Here we have to use subcommand called as mkdirs, then dbfs : you have to specify the path using which you wanted to create the folder. To confirm if the folder already exists or not, you should be able to use this command %fs ls dbfs : data. Let's check whether this folder exists or not. It is currently running. We have to wait until it is fully run. You can see it is saying file not found /data. Now let's say %fs mkdirs, then dbfs : data. Also, I would like to add subfolders by saying online retail followed by revenue by invoice or invoice revenue. Let me name the folder as invoice revenue. Let's see what happens when we have this entire folder structure. It might create the entire folder structure without any issues. We will see whether it will be successfully run or not. You can see it is successfully run. Now we should be able to validate by saying %fs ls, then dbfs data online retail invoice revenue. As of now, there are no files in this location, hence it is empty. However, if you want to clean up this folder, you just have to use this command %fs then rm. rm will attempt to delete files. If you just pass the folder to rm command, it will fail because it is not a file, it is a folder. In case if you have to delete a folder, not a file, then you have to use -r for recursive. I'm surprised to see it have ran successfully. I thought it will fail. I might have to specify -r to delete the folder. However, even without having -r, it has successfully deleted the folder. To confirm whether the folder is successfully deleted or not, we should be able to run this command once again. It should fail with the error. You can see it is saying file not found exception, and it has specified the path which we are trying to list from. This is how you should be able to manage files and folders in DBFS using fs command. Once again, I am reiterating, DBFS stands for Databricks File System. Now, before getting into the details about writing data to specified location, let me make sure I have base folder. The base folder will be DBFS data online retail. I just have to use mkdirs command. As part of the mkdirs command, I need to remove invoice_revenue. I'll specify invoice revenue as a target folder while writing data to that folder at a later point in time. For now, I just wanted to have base folder data online retail. It is successfully created. You can also validate by using this command. Let me clean up the subfolder invoice revenue. As there are no folders or files in online retail, it will just show empty. You can see it haven't thrown any error. At the same time, it haven't shown any files or folders. The reason is the folder is as of now empty. As soon as we attempt to write to this location specifying the subfolder, the folder will be automatically be created. Now let's get into the details about how to use this base location to write the processed data into DBFS. As we have gone through quite a few important commands to manage files and folders in DBFS, now it is time for us to write the processed data into this location. Let's make sure we copy this path because I would like to specify this path while writing data to. Even though this folder is not there, it will be automatically be created. Now let's go back to the other notebook. Let me go to recents here. Now let me go to getting started with PySpark. Again, we'll be using run all so that all the cells in this notebook are run successfully. Once all the cells are run, then we should be able to come up with the logic to write the processed data to DBFS. Already I have copied the path. I'll be pasting it once I come up with the required logic. The logic will look like this. First, you have to start with the data frame. The data frame name is nothing but invoice revenue df. So here we have to say invoice revenue df. Then you can actually say write. When it comes to write on top of data frame, it is nothing but attribute. It exposes quite a few functions with respect to writing data into different file formats. First, let me line break here. Then we have to specify the function based on the file format which you wanted to use. It can be CSV, it can be JSON, it can be Parquet. Also, it supports other file formats such as Avro, Delta, etc. For now, we'll keep it as Parquet. Let me say Parquet here. Then I have to specify the path. The path is nothing but this one. Keep in mind, earlier we have only created this folder. We haven't created this subfolder. It will be automatically be created and Parquet files will be generated in this folder. Now let's run this. It will take care of running this piece of code. The data will be written to DBFS. Let's wait until it is run. Then we will validate. Now it is successfully run. You can validate by using %fsls command. Let me copy this. Let me say %fsls, then paste. Then let me run this. You can see the outcome. Under this location, there is one file. The file is nothing but this one. You can see when it comes to the extension of this file, it is nothing but snappy.parquet, which means it is a file of type Parquet. Also, it is compressed using the snappy algorithm. That being said, this is how you should be able to write the processed data into DBFS using different file formats. Here we have used Parquet. However, you should be able to use any of the supported file formats such as CSV, JSON or Parquet, or even there are few third-party file formats which are supported. However, the syntax is a little bit different when it comes to third-party file formats. Also, let's review whether data is properly stored in this location or not. For that purpose, we have to read the data from this location and then we should be able to create a data frame. Once the data frame is created, we should be able to validate. So in this case, let me name the data frame name as df underscore. Just I wanted to have underscore at the end because we already have df while reading the data from the CSV files. As we are attempting to read the data from Parquet files, I just wanted to use the df underscore like this. Then I can say spark.read. Read is also attribute under Spark. It exposes several APIs. One of them is nothing but CSV, which we have used earlier. On top of CSV, it also supports other file formats such as Parquet, JSON, etc. Now, in this case, let me say Parquet because we are attempting to read from Parquet files in this location. The location is nothing but this one. Let me copy this. Keep in mind, you have to pass the path as a string. Hence, you have to enclose either in single quotes or double quotes. I am using single quotes here. Then you have to paste the path. Then you should be able to run this. It will create a data frame by name df underscore by reading data from Parquet files in this location. You should be able to see the details with respect to this data frame by expanding this. You can see it have 4 fields. They are nothing but invoice number, invoice revenue, invoice item count, and invoice quantity. Now you should be able to preview the data by saying df.display. Once you run, you should be able to see the data in tabular format. However, you can see that it have more than 4 columns. It is because I have used incorrect data frame name. In this case, I have to change this to df underscore. Now let me run this. Now you can review the outcome. It have only 4 fields, not additional fields. It is because we have used correct data frame name. Let's scroll down further. You can see there are 2888 rows in this data frame. In case if you wanted to just get the count, you should be able to say df underscore dot count. It will only show the count. This is how you should be able to validate to see if data is returned to the target as per the expectations or not. That being said, we have gone through the entire life cycle of reading the data from CSV files, then processing the data by applying required logic to get metrics at each invoice level. Also, we have seen how to write this processed data into DBFS. For all the purposes, we have used Spark-based approach. And how much money we have spent? $0. How simple it is? Very, very simple. Do we need to enter our credit card information? No need. You just have to sign up and then you can start using this Databricks Community Edition to learn Spark. One of the key aspects using Spark to process the data is ability to troubleshoot the issues. We can use something called as Spark UI to troubleshoot the issues. I'll also cover the details with respect to Spark UI within Databricks Community Edition itself.
Congratulations on completing this tutorial, and I hope you really enjoy this tutorial. Like I said, in case if you have not subscribed to our ITversity YouTube channel, please consider doing it. Like, comment, and share it with your friends this video. And most importantly, like I said, watch this space for more tech related content. You can also check out our channel. We have a lot of content, for example, especially in the areas of generative AI, data engineering. We have free tutorials. So if you spend a minute, just go through these topics and pick up the ones you are interested and start learning right away. So watch this space, we will come up with more content, and especially this playlist, right? So as of now, you can see that we have RDDs and data frames in this playlist. We also plan to add content on a weekly basis. Check out this space, you will see more content related to Spark SQL, you will see content related to Delta Lake, you will see content related to Spark streaming, all coming, a lot of content on your way. So this is Raghu signing off, and I really hope you enjoyed the content. We'll see you next time. Bye-bye.